Hi folks, I'm going to move into, we're past conditionals and I'm going to move into looping and iteration, but I just want to note something about the PowerPoint that I've got in here. I've got some extra information in here that probably shouldn't be in here, and so if you see it, I don't want you to panic, I'm going to strip it out. I've got loops and strings in here. I had actually pulled out all this string information and made it a later unit. I think it was 4.6. So I did go through strings with you in the last video, but really this information probably should have come a couple of lessons later. So if it was a little fuzzy, that's fine. I'll be going over it again. And then I said there's some loops here, but we haven't discussed loops. So I'm going to pull that out as well. And this basic cryptocurrency or cryptography exercise, you won't be able to do yet. So don't worry about that. So basically, if you're on what are we on here? 4.5 conditionals, or is 4.4? I guess I better check that for you, eh? If you are on 4.4 conditionals, you can basically ignore from strings onward, and I will put up a new PowerPoint just so that we keep things sort of in better order, because I asked you to do some things in that last section that you don't know how to do yet. So just to be aware of that. Now, 4.5 loop. This is where we really want to talk about looping. So looping is, again, the last of the big five that we have to discuss. Okay, we did input output, we've done variables, we've done functions, we've done conditionals, the if, elif, and else, and now we're going to do the very last of the major tenets of computer science and programming, and that is looping, which is also called repeating and iteration, but most of the time you'll see it as looping. Okay, now looping is just the act of repeating an action so that your program can be flexible and it can take more than one set of data. If your program is only able to ask you, what's your name, and it's only able to ask it once, well, you can only store one person's name in there. Whereas if you can repeat it, you can store as many people as you like. There's a bunch of different types of loops, but the two that we're going to focus on mostly are going to be while loops and for loops. Okay? While loops, okay, they start with the word while, and then there's some sort of test. Just like in an if statement, there's like a logic test here. And as long as that logic test is true, it's going to keep looping this over and over. As usual, there's an indent, so anything that's indented under the while is part of this while loop. Let's use this example right here. This is something called a sentinel or a flag, where basically it's one of those things where you ask the user to enter a special character when they're done. And it's just a flag to tell you that, okay, stop taking information. So in this case, what we're going to do is we're going to add integers that are entered by the user until they tell us to stop. And they're going to tell us to stop by entering -1. Okay, so that makes this a sentinel loop. But really, it's just saying -1 is going to be our flag, and our flag is going to tell us to stop looping. So we're going to start with two variables, a sum that equals 0, and then the number, or num, is going to be whatever they type in. And then we're going to have a while loop. And I'm actually going to run this program, or I'm going to build this program in Thonny so we can step through it step by step to hopefully make our lives a little easier. So we were summing two numbers, so I'm going to set a variable that equals 0 for sum. And then I'm going to put num as 0 as well. And that's going to be the number that keeps getting entered by the user. Okay, so our first thing we need to do is we need to get a number from the user. Okay, so let's set the num. Okay, we set it to 0 up here, but we're going to change it now. Num equals, and we're going to make it, let's make it a float so they can put in decimals. And it's input, so we need input. And then we're just going to tell them enter a number. And then we're also going to tell them enter 0, actually -1, to end. Okay, enter their number, enter -1 to end, and then I'll just put a couple spaces. I got two brackets, so I got to end them. Okay, so these two brackets here are inside the quotes, so it just treats them like the character bracket. It's not like a function bracket. I could have done something like this. Enter -1 to end instead of the brackets. Whatever you want. But if it's inside quotes, it usually just treats it as letters. So we're going to get a number from the user, and we're going to convert it to a float. So if they put in 4, it's going to be 4.0. If they put in 5.5, it's going to be fine. And then what do we want to do with that number? Well, we want to continue to take numbers and display the sum, the running total, until they tell us to stop. So that, whenever we don't know how many times something has to run, whenever we're relying on the user to tell us when to stop, it's almost always a while loop. Okay? We always use whiles when we don't know when to stop. We have to get some input from the user. So our logic here, and I usually put my logic in brackets, is while the number is not equal to, remember exclamation equals, that's not equal. So while the number is not equal to -1, I want to keep looping. So that's what this says. This says as long as the number isn't -1, I'm going to run everything underneath. Okay, so I'm just going to, maybe I'll just keep this clear by, I'm going to print, you entered the number, okay, you entered the number, comma, and then num. You entered the number num, and then I'm going to print the new sum is, and then I'm going to put the sum. Except before I print the sum, I should probably calculate the sum, right? So the sum has to be, now you could do the sum equals the sum plus the number, so that's going to take the old sum, add the number, and then make that the new sum. But remember, the short version of this, and I want to get us used to using the short version of this is plus equals. So the sum is going to be updated by whatever I have after it, which is the number. So sum starts at 0. We're going to get a number. We're going to add that number to sum. We're going to tell them what you picked. We're going to say we're going to do the calculation. And then we're going to say this is the new sum. And as long as you don't enter -1, it should keep going forever. When it's done, okay, now look, this is no longer indented under the while. Okay, it's no longer indented, which means as soon as the while is done, it'll loop, 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 loop as many times as we want it to loop. And then when it's done, okay, I'll say the final sum is sum. So we'll just print out at the very end, we'll print out what the final sum is. So let's just check it and see if it works and see if we need to change any of our logic. Okay. So let's run the program, enter a number, -1 to end, 4. I've got an endless loop. I'm glad that happened. Oh, it's the bane of all programming existence, the endless loop, the infinite loop. It's going to loop forever, and this number is just going to continue to be 4, and it's going to keep adding 4 until my computer crashes because it can't handle it. Major programming error, the infinite loop. My logic up here is not appropriate. It says, while the number is not equal to -1, I want you to keep running this. Here's the problem. Okay, here's the problem. I asked for my number outside of the loop. Okay, I asked for a number outside of the loop. So when it gets into the loop, it says you entered this number. And then it computes the sum, and then it says the new number is sum, and then it goes back up and runs the while again. So it's always operating in here. But if it's always operating in here and looping around in this area, we never get a chance to enter another number. So I actually should either duplicate this, or I'll just make it easier by taking this out and putting it as the first line in my while statement. So my while, or my number, my num, starts out as 0. So it says while num is not equal to -1, it's going to run this. So because num starts out as 0, we know that 0 is not equal to 1, so this evaluates to true, which means it's going to run this first line. You want to make sure it runs the first line so that you get a chance to enter a number. And now, every time that you loop through this, it checks every time, and you'll be able to put in a new number every time. So this time, it won't be an infinite loop. Okay, enter a number. Let's enter 4. You entered the number 4. The new sum is 4. Enter a number. Well, now I'll enter 5. You entered number 5. The new sum is 9. I'm going to enter 345. You entered 345. Your new sum is 354. So it's just going to keep adding numbers as long as I want it to. And eventually, I'm going to type in -1. And it's going to end the program. It's going to say the new sum is 1175 and the final sum is 1175. All right, let's look through. Okay, let's look through our logic by debugging this so that you can see what's happening step by step. I put in global variables at the top. I'm going to need a sum variable. I'm going to need a num variable. Now it goes down to the while loop, and it says, okay, as long as this condition is true, I'm going to run the stuff underneath it. So I've got to check the condition first. And the condition is the number not equal to -1? Well, the number right now is 0, because I told it to be. Is that not equal to -1? That is true, because 0 is not equal to -1, which means because this is true, it's going to go into the loop and start running it. So now it runs the get a number part, and I'm going to enter 5. So now it says, take 5, turn it into a float, which is 5.0. I entered the number 5, so it prints out 5.0. Okay. Now it goes down to the sum and says, well, the sum is currently 0, but I need to add 5 to that. So now my sum is 5.0, and now I'm printing the new sum is 5.0. Now our number, now we're at the end of the loop, so we loop back up to the top, and it checks the condition again. It checks it every time. It has to check it every time. So now it's checking it again. Is the number not equal to -1? Well, that's still true, because I didn't put in -1, I put in 5. So it knows that I'm going to run this again. Okay, so now I'm going to enter a new number. Let's enter 6 this time. Okay, so I got 6. It turned it into 6.0. It computes the new sum. It's going to say, well, my old sum was 5. Now I got to add 6 to it, so it should be 11. And then it's going to print the new sum is 11. And now it needs to check again. Should I still run? Yes, I should still run. Now I'm going to tell it to stop. Okay, now I'm going to enter the flag. The flag was -1. That was the cue to stop. Okay, so when I enter -1, it says float -1. Okay, you entered the number -1. Okay, now it's actually going to compute this in my sum, so it is actually going to subtract that. Okay, which it may be a bit of a logic error because I went from 11 to 10, so it actually computed my -1 into into the sum calculation. So, you know, if you wanted that to not happen, you would have to add 1 at the end to take care of that. But in this case, we'll just leave it as it is. The important part is when it loops back up to the top, it's saying it's doing its normal check that it does every time. Is the num variable not equal to -1? Well, this time, -1, okay, is -1 not equal to -1? That becomes false, because -1 is equal to -1. So this statement now is false because I specifically put in -1. If this is false, it doesn't run it anymore. So it skips over it, doesn't run it. So it looped how many times? 1, 2, 3. It looped 3 times or 2 times. And then I told it to stop looping by putting in -1. And now it skips out of the while loop. It just goes down to the next statement of the program, the next command, which is print the final sum, which it will say is 10. Again, if you wanted this to account for that -1 and not add it in, okay, you would do something like this. Stop debugging. It would just be another layer of logic. You can have if statements anywhere. You can have if statements inside other if statements, inside other if statements. You can have if statements inside of while statements. So let's just do this. If num is equal to -1. So if num is equal to -1, I should make that in brackets. Okay. Then what are we going to do? If num is equal to -1, then sum is going to be plus equal the number. No, if sum is equal to -1, I don't want to change the sum. So if not num equals -1, so if the number is anything but -1, okay, then it's going to add the number to the sum. If the number is -1, that's going to be false, so it's going to skip over it. Okay. Another way you could have done this is if, let's see, if you didn't want to use the not character, some people don't like using nots, that's fine. You could do two sets of logic. So if the number is not equal, the easier way of doing it, if it's not equal to -1, then you're going to add whatever the number is to sum. And because we don't need an else, We just need to take care of this. This should work fine. So the if statement, all the if statement is doing is adding another layer of logic. So if I'm in here and I just entered -1, it's not going to update the sum. If I enter any other number, this becomes true, and then I am going to update the sum. So basically, it's going to take care of that thing where I wanted to end the program at 11. I entered -1, and because I entered -1 as my flag, it changed it to 10. If I didn't want that to happen, this little layer of logic would help it. So let's just make sure that's working. Enter a number 4, your sum is 4. Enter a number 6, your sum is 10. Now if I enter -1, hopefully it doesn't change my sum and make it 9. It didn't. It said the new sum is 10, the final sum is 10. So just this little chunk of logic here, and there were a bunch of different ways we could have done this. Just this little chunk of logic here solved our problem where it subtracted the 1 from the sum. Okay, that wasn't really the point of this exercise, though. The point was to show you how a while loop will continue looping until this condition is false. Very, very important. Okay, now you can have an else. It seems a bit odd, but you can have an else on a while. So if you have, very similar to what we just ran, while test, and then whatever's happening in the while loop, you can also have an else. So if it doesn't run the while, it will run the else. Okay, so if it doesn't run the while, it will run the else. Okay. Just think of a quick example for that. Maybe modify this program here. While number is not equal to -1, it's going to run this. Let's see if I put an else in. Else, let's see, else print the final sum is. So in this case, if this is true, it's going to keep doing the loop forever. If this is false, okay, I'll say the loop did not run. Okay, so if I start at sum equals 0, okay, it should run. Enter a number 5, 4, 6, 2. Okay. Oh, I didn't update the sum. I was wondering why that wasn't happening there. So sum would be plus equals none. Sorry, I'll just run that again. Okay, so first number is 5, 4, so we're at 9, 8. Okay, -1, it stops. Okay, the new sum is 16. The loop did not run 16. So basically what happened there is it ran this loop until it couldn't run it anymore. And as soon as it can't run it anymore, as soon as this is false, it'll skip down to the else. Now in this case, it did the exact same thing as just putting this after and outside of the while loop. But it's just a different option for you. If you need to have another option for it not running the while, you can have a different option. Like for instance, if they didn't enter the right data, you could use the else statement to let them enter data again. It might help you with your program flow. So you can have an else. In this particular instance, n equals 91, while n mod 2 is equal to 1. Okay, n is plus equal 1. I can't remember if I did modulus in a previous video, so I'm going to do a quick little thing on modulus, because you're going to use it for several of your programs. I'm just going to move over to the window here so I can write something. Okay, so modulus. You may not have seen this in math. Okay, in Python, it is the percent sign. All it is the remainder of division. So if you have, now that I think of it, I think I did do this, so this should be a quick review. If you have something like 7 percent sign 3, what is that actually going to return, or how does a computer deal with that? Well, what it does is it does a division statement, just like you would have done in grade 3, I think, and it tells you what the remainder is. So if I divided 7 by 3, well, that would be 2, correct? 2 times 6 is 2 times 3 is 6, and then 7 minus 6 is 1. So this is the remainder, right? And in grade 3, you might have done something like 2R1 or something like that. This is what it returns. Okay? It doesn't return the 2. It doesn't return what we would typically think of as the answer for a division statement. It returns the remainder. Okay, so let's do a couple more over here. Okay, so let's do 15 mod 3. Let's do 3 mod 15. And my pen's going wacky again. 3 mod 15. Let's do 20 mod 6. And let's do 0 mod. I'm not going to do 0 mods. It's always 0. Let's do 5 mod 300. Let's see what happens here. Okay, now the order is very important, right? Because it's always like this, front divided by back. So 5 mod 3, still a little work area down here, is basically, okay, 15 divided by 3. Well, it goes in evenly, right? So 3 times 5 is 15. There's 0 remainder. So the remainder is 0. It doesn't put 5, it puts the remainder. Now let's do it the other way around. What if it's 15 divided by 3? Okay? What is 3 divided by 15? Does 15 fit into 3 any time? Okay? It doesn't. So there's always going to be a 3 remainder on that one. 15 will never be able to fit into 3. Okay? And we're just dealing with integers here, no decimals. So the deal is, and the important part on this one right here, is that every time you have a number here that is smaller than this number, your answer is always going to be the smaller number. But that's only if it's in front, okay? If it's in, obviously if the number is over here, you're going to get all sorts of different remainders. But when this number is smaller than this number, your answer or your modulus is always going to be that number. So if we do 20 mod 6, okay, so if we just go down to my work area here, that's really 20 divided by 6. How many times does 6 go into 20? It goes 3 times, which gives you a remainder of 2. So 20 mod 6, your computer reads that as 2. 5 mod 300, this number's smaller than this number, so you don't have to do any math. You just know that if this number is smaller than this number, that's going to be the result. So it is important that you understand modulus and you know that it's a percent sign and you know how to use it. And if it takes a little practice, that's fine. It takes a little practice. But it is an important concept in computer science and one that you don't necessarily spend a whole lot of time on in any of your more seniorish math classes. I don't think it plays a big role in calc or foundations or workplace. So we discussed already and gave examples of while loops. And I told you that while loops are specifically for when we don't know how many times the program needs to loop. We need to rely on the user or some condition to tell us when to stop. The other main type of loop is a for loop. And I would say you use both of these loops equally much. For loops are when you know how many times you want to repeat. You don't need to rely on the user to give you input to tell you to stop. You know I need to repeat this 10 times, or I need to repeat this 7 times. You can use and should use a for statement. And this is how they are, built. It's for I in range, the low end, and this is basically the high end plus 1. So, you got to think of sort of minus 1 on this one. So for I in range, do something. Okay? Now, when you're inside a for loop, this is just a variable. It says I. You could have named that name, number, letter 1, employee 5. It doesn't matter. This is just a variable that you set for your for statement. It's a local variable, which means this I is only in play as long as you're inside that that for loop. So what this is going to do is it's going to start your variable at 0. Okay, we're dealing with numbers here. We're starting with 0. Okay, and then as long as it's between 0 and 5, really, it's going to print what it is. So the first time through the loop, I is 0. So that's true. It's in that range. So it's going to print I, which is 0. Then it automatically, you don't need to do it, it automatically changes this to the next one. So instead of 0, it's going to be 1. Is it still in that range? Yes, that's true. So it's going to print 1. Then it changes to 2, 3, 4, 5, prints all of them. Eventually, after it's done 5, I is equal to 6. And it asks, is 6 in the range of 0 to 6? It looks like it is, but it isn't, because we know this only goes to 5, right? So that's false. Now it skips out and ends the program. If you don't have this 0 in front, remember, it assumes 0. So if you just say for I in range 6, it's 0 to 5. If you say for I in range 3 to 7, starts here and then ends one less than that, right? So it starts at 3, 4, 5, 6. It doesn't include 7. It's always one less than that. Okay, let's put this into practice on Fawny here. Okay, I'll clear out our input or output. And what am I going to do? I'm just going to do a straight up for loop. Okay, so I'm going to, for the number, remember this is just any variable name. As long as it's a legal variable name, it's all good. For the number in range, let's do 100. Okay, print the number. So what it's going to do is it's going to start at 0, and it's going to print 0, and then it's going to keep looping all the way up to 99. It's going to print 99, and then as soon as it gets to the 100th loop, this is going to be false, and then it's going to print what I want it to. So I'm outside of the loop now. Now I'm just going to print, we're done. Okay, so let's see what happens. I run it. It printed from 0, you can't see it because it's way up here, from 0 to 99, and then it stopped looping, skipped out of the loop, went to the next line of code, and said, we're done. We talked about local versus global variables. Okay, the number in this case is a variable, and I could have called it whatever I wanted. I could have called it x, right? Doesn't matter. In fact, I often do call these for x in or for letter in or something. The program runs just the same if I call it x. But this x only exists here in this little loop. It does not exist outside. Watch what happens when I try to print x outside of the loop. So this is all printing x inside the loop, but what about when the loop's done? Does it still know what x is? It doesn't. Oh, it does. Oh, why did it remember that? Hold on. Let's just set a different x up here. 5 is a global variable. This might be something that changed from 2.7 to 3.0. Oh, okay, it did. Sorry, this is considered a global variable. So if you have an existing x before, it will overwrite your global with whatever this x is. Because look at the end. It printed to 99 in here, and then it printed 99 one more time at the end because it did change x. I'm sorry, this is not a local variable. This is a global variable, so it will impact what you have up here. So, for instance, if I print x at the beginning of my program, it'll print 5 because 5 is what x is at the beginning. Then x changes through all this looping, and then at the end, it'll be the last number, which was 99. So if I run it again, first number it prints should be 5. Yep, there it is, 5. Then it goes into the loop, and it changes the x value to 0, 1, 2, 3, 4, all the way up to 99. And then at the end, it jumps out of the loop to the last line of your program, and x is still 99. So it starts at 5, runs through the program, gets to 99, and then at the end it's still 99, so I printed it out again. Okay, that is actually important, that it treats, that looping, for loops treat the variable as a global variable, not a local variable. So that's not like if statements. If this was an if statement, okay, then it wouldn't know what this was. Maybe I should do an example of that. Okay, so let's say, let's just say x equals 3, and then if x equals 3, remember to use the 2, remember to use the 2 equal sign if you're testing something. If x equals 3, okay, I'm going to have another variable in here, y equals 5. Okay. Print y, and then I'm just going to test and see. If I can print the y from inside. So I'm testing the if statement. Okay, so x equals 3. If x equals 3, that's true. Y equals 5. Print y. So it printed 5. Then it printed x, which is 3, and then it printed y again. Okay, so it is considered global inside a y statement too. That's good. So if statements, while statements, and if statements, while statements, and for statements, you can change your x's with the if, while, for, but here's where it doesn't work. Let's do a function, okay? So x equals 3. Now we'll do a function, def test function. It doesn't even matter what it is. I'm going to set a variable in my text function called y, and y is going to be equal to 4. Okay. So watch what happens. I can print x, but watch what happens when I try to print y. Okay. Error. It says y is not defined. So this is An important concept. X is a global variable. Y is only inside my function. So Y is considered a local variable. Okay, it only works inside this function. Okay, so when I tried to access Y outside of the function, it said, I don't know what Y is. I can see, as a human, that there's a Y right there, but the computer, I never told it to go to this function. I never said, go do the test function. So it has no idea what Y is. In fact, even if I tell it to go to the test function, because I didn't tell it to do anything with that variable in the test function, it's still going to give me an error. Okay? It still says Y is not defined. Why? Well, it knows what X is, and then I go to test function, and then it momentarily knows what Y is right here, because I'm inside the function, but I never did anything with it. I didn't print it, I didn't return it, I didn't do anything with it, so then it just leaves the function. So for that brief period of time, Y equaled 4, but I didn't do anything with it. And then when it gets down to print Y here, it completely forgets that it looked up here in the function. Okay, so as far as it's concerned, Y was never a thing. In order to fix that, okay, you'd either have to return it, okay, or you would make this a void function, and you would just say something to the effect of print Y. So it can print Y in here because inside this function, it knows what Y is. It says Y equals 4, so I can print it. But outside the function, it doesn't know. So if I run this one, it's going to print the X, then it's going to go to the function, it's going to say Y equals 4, then it's going to print the Y. So this one will actually work. 3, 4. But what won't work is if I try to print Y outside of the function, because it doesn't know what Y is anywhere outside of this spot. Hopefully that cleared it up. Again, I thought that was the case with if statements and whiles and fors, but that is not the case with them. It is only the case with functions. All right, so our for statements, we've discussed how to do range, we've discussed how to change the low end, but there's some more things you can do. You can be stepping through with a third argument. So just like you separated the first two with a comma, you can separate the second two with a comma as well. So if you do something like for I in the range of start at 0, end at 5, skip by 2, every time that it prints the I, when it goes back up, it adds 2. So instead of adding 1 every time, it'll add 2. I'll show you how this plays out in Thani. Okay, so just very simple. For X, or for, I'll call it number 1 or something like that. For number 1 in range, and this time we're going to start at 0, we're going to end at 11, and we're going to step by 2. Print number 1. Right, so for number 1 in range, starting at 0, ending at 10, stepping by 2, print. So it's only going to print every second number. 0, 2, 4, 6, 8, 10. So number 1 started as 0, so it printed 0. Then when we went back up to loop again, it changed it to 2. Because it skipped right over 1 because I told it to skip. Okay, so then it printed 2, skipped to 4, skipped to 6. You don't have to have this as 2. What happens if I change it to 3? Okay, now it prints 0, 3, 6, 9, right? So the first time it's 0. Okay, it prints it. Then it skips and adds 3. So now it's 3 and adds 3 more. Now it's 6 and adds 3 more. It's 9 and then adds 3 more. It's 12. And as soon as it's 12, it's outside the range, right? You can skip by 10. And this time it'll only print 1 number. Or, sorry, 2 numbers. So it'll print 0 and 10, right? It starts at 0. Okay, prints the 0, and then it adds 10 to it, and then it prints the 10, and then it adds another 10, and now it's at 20, and 20 is outside of this initial range. The range is the first 2. This is what it steps. You can also do negative steps. So if I step -2, let's say I start at, instead of starting at 0, let's say I start at 12, and I end at 0, and I step by -2, and I print. Okay? It starts at 12, 10, 8, 6, 4, 2. So this time I said, number 1 is going to start at 12, and the range I'm checking is it between 12 and 0, but I'm going down by 2 every time. So number 1 is 12, I print it. Now I'm going to go down by 2, so I'm at 10, and then I'm at 8, and then I'm at 6, etc. So you can step up and down, depending on whether you have a negative sign in front of this or not. If you're stepping down, if you're going backwards, make sure that you switch these 2 numbers, because if I try to step down from 0, okay, it doesn't do anything because it starts at 0, okay, and then it tries to go to 2. So it doesn't know what to do. So it just basically does nothing. So if you're doing a negative step, usually you got to switch these two numbers around. And just like with positive stepping, you can step down by any value. So let's step down by -5. So it'll print 12, then it'll go down 5, it'll print, it'll go down 5 again, it'll print. And then as soon as it's done with the 2, it tries to subtract 5, and then we get into the negative numbers, and the negative numbers are no longer in the range of 0 to 12. Okay, so that's why it only ran up until 2. As soon as it hits a negative number, as soon as it's less than 0, it's not in that range anymore, so it knows that it's got to stop. So that's stepping up, that's stepping down. Okay. You can use for statements with strings and lists. You don't know what lists are yet, but it's going to be very important that you understand that you can loop through them when we get to lists. So this is a very simple example, just with a word. I'll go over to Thani, and we'll just program this in. Okay. So for letter in, I'm gonna actually create a variable. So I'm just gonna create a variable called word equals hello CS20 students. Okay. For each letter in word, it's actually a sentence, but I called it word. Okay, let's print letter. Remember, letter is just a variable. Okay, it's just, I could have called this X. Okay, in fact, I'll call it X. For X in Word, print X. So it's going to start at the beginning, and it's going to print everything. Okay? One line at a time. Here we go. Hello, CS20 students. One letter per line. So let's look at that in debug mode and see what's actually happening. Okay? So it sets our variable as a string, hello, CS20 students. That one's pretty obvious. Now it's the loop for X in Word. Well, it says, what is Word? Oh, okay, I know what Word is. It's that. For X, the first one is an H. X is H. So it prints H. Now it goes to the next letter, which would be index 1. So when it's index 1, it actually means it's the second character there. So it's now E, then it gets the L, then it gets the other L, then an O, and it does print the space. Okay, so after this, it'll print the space. Then it goes to the CS, and then it just keeps looping through. So you watch how X changes over here. Okay, right? Every time you loop through, it changes what X is, and then when you're done with it, and it's done, it skips out. X is just the last thing it was, and then you found that one per line, you have printed each letter. Okay? So you can do it with any strings as well. I believe that you could also do, I'm just going to check this one. Let's do 2 to 6. X in Word 2 to 6. Will that work? Nope, doesn't like that. Okay, well, too bad. Point is, you can use it on strings, you can use it on numbers, you can use it in ranges of numbers, and so on. This is a list of things. I think I'm going to skip this for now because lists is our next unit, and lists are very important, and I don't want to just, I don't want to trivialize it. So I'm going to leave this out and leave that for a different one. I've mentioned this several times before, that one of the data types, one of the main data types is called bool. It's named after the guy's name was George Boole, and it's often called Boolean. Okay, and the only two options for bool are true with capital T, by the way, and false with capital F. Okay. So true and false are also things that you can get your computer to test or return you a value of true or false, or however you need to use it. Every if statement uses a Boolean test. Okay. Remember, if you have an if statement, it's testing something. It can either be true or false. So every time you're running an if statement, you're actually using Boolean. Okay. Either the test is true or the test is false. Same thing with loops. If you've got that loop, that while loop, it's always testing. Okay, let's say you have that exact program that we had before where you enter numbers and then you enter -1 when you want to stop. It's always testing every time through the loop. Is your number -1? If it's true, then it's going to do something. If it's false, it's going to do something else. So Boolean comes into every data structure that has a loop or a conditional. Same thing for the for loops. For X in range 0 to 10. It's testing every time through the loop. Should I be done yet? Should I be done yet? True or false? Am I still in the range? True or false? Am I still in the range? But if you just enter stuff into Python as a program, it will give you bool results. So if 5 is less than 10, that's true. How might that work in Thonny? Let's just say I tried to print it. Okay, so print, okay, 5 less than 10. I'm asking it to print this. I'm not telling it to print the number 5 and then the sign and then the number 10. I'm saying print the result of this, and the result of that is true. Okay, print 5 equals 10. That should print false because it's not. Print 5 equals 5. That should be true. Okay, okay, print, let's do a different one here. Let's print not true and false or 5 equals 5. See what that prints. True. Oh, why? Because this is true, that's in brackets, and then we do the not, right? So not true is false. So we did the not true, that's false, and this is true. So we end up with false and false or true. So we took care of the N. What's next? A. So we had false and false, that's false. Okay, and then we've got or, so we were left with all of this stuff evaluated to, all this stuff evaluated to false. And this one evaluated to true. So at the end of the line, we were left with false or true. And false or true is true. If I put another not in front of that, see, I can just wrap logic in here. We knew that this whole thing here ended up as being true. So if we say it's not true, then our answer is going to be false. So this time it's false. And that was just a review of the nots, the ands, and the ors. Remember, you got to do brackets first, then you go to the nots. Okay, so we had brackets here, and we also had brackets here. So it's got to do the brackets first, then it goes to the nots, then it goes to the ands, and then the ors. So neo and ao. Okay, so this is a complete review of something I already talked about, NAO. Okay, it does not first, it does and second, it does or. So 5 is less than 10, that's true. Not true means the opposite, false. Not true, well, it's going to do this one first, so not true is false, and then not false is true. True or false is true, true or true is true, false or true is true. True equals true, also true. True and true is true, true and false is false. Remember, it's both, it's got to be both with and. Both got to be true. False or false and true. Well, by neo, we don't have any nots, but we have an n. So false and true is going to be false. False or false is going to be false. Then we've got not or and. Let's do the not first. Not false is true. Okay, and then we got to do the and. So we've got a true over here. Then we've got true and false is false. Okay, so we've got a true or false at the very end. And true or false is true. It's just order of operations. It's like bed mass for the words not and or. And don't forget about the brackets. I mean, the brackets come before anything else. Random numbers. Okay, there is a special math library. It's not in the math library. It's in its own library called random. So from random, import star imports everything from random. If you want to get a random number, which is very often the case in programs, let's say you're making like a dice program and you want a random number between 1 and 6, you can do rand int and then put the low number and the high number. So it'll just return an integer inside those. Okay. Here's an example down here. Random int between 1 and 5 gives you 2. In this case, because it's a special function in a special library, random being that special library, it includes this number. It doesn't go to 4. It goes from 1 all the way to 5. So this is literally the low number, literally the high number. So if you ask for a random int between 1 and 5, it can be 1 and it can be 5. If you ask it to choose, okay, it'll choose in a range of whatever you want it to do. So the range will be between 4 and 20, but it can only be in steps of 2. So it can't pick 5. It can only pick 4, 6, 8, 10, 12, 14, 16, 18, or 20. It can't pick 5 or 7 or anything that's not a multiple of 2 because it has to step at 2 every time, right? And it can't be less than 4 and it can't be greater than 20. So in this case, it said make a choice in this range, okay, with only even numbers, and it said, okay, 16. If you said choice hello, it just randomly picks a letter. In this case, it picked E. Next time, it might pick L. We know all of these logical operators. We've gone through this chart before, so I won't do it again. Okay, now here's a nice exercise. Write a program in Python that randomly rolls 2 dice and calculates how long it takes the user to roll a 7. So the user is basically, you have to get a random number and another random number, add them together, and check if it's a 7. If it's not a 7, you have to keep going. And then when you finally do get a 7, the program has to tell you how many times it took, right? So we've done stuff like this in Scratch already. So if we can think back to our logic in Scratch, we should be able to build this program knowing what we know about the looping and variables and conditionals inside of Python. So now's a good chance to pause, okay, the video and go try it on your own. In about 5 seconds here, I'm going to actually go do it with you or for you, and you can check to see if you were on the right track. Okay, so let's go build this in Thonny. We've got 2 dice, and how many times does it take us to roll a 7? Okay, so that's basically what I need to know logic-wise. Okay, let's just start from scratch here. I'm going to clear all this. All right, well, I need 2 dice rolls for sure, so I'm just going to call, it's actually a die. A dice is a die. I'm going to call die 1 and die 2, and they both equal 0. Okay, I'm going to create a function to roll the dice because it's something I need to do more than once. Why would I copy and paste my code when I can create a function? So I'm going to create a function called roll dice, and I need to accept 2 things. I need to accept dice 1 and dice 2. So I'm just going to call that d1. No, I don't need to accept anything, actually, as a matter of fact. So I'm going to have a function called roll dice. Now I am going to set a variable called d1, and that is going to be the, sometimes I put comments in here to remind myself of what I'm doing. This is going to be dice 1 roll, die 1 roll, and then I'm going to have d2 equals something, and that's going to be die 2 roll. All right, now to do any random numbers, I need to import the random library. So from library import, or not from library, from random, sorry, import star. So that imports everything in the random. All right, so we've got def roll dice. We need to get a die 1 roll and a die 2 roll. Well, each of these rolls has to be between 1 and 6 because that's all that we can fit. That's all we have on dice, right? So d1 should be rand int. Can't remember if that's a capital letter or not. We'll try it without. Rand int between 1 and 6. And then the same thing for dice 2. And it can be the same number, right? Like, it's very possible we roll 2 3s, right? So rand int 1 to 6. That'll be our second roll. Now we need to, okay. Now let's add them up. Sum. Actually, no, let's print. Okay. Dice roll 1, or die 1, you rolled a comma d1. Okay, dice 1, you rolled d1, and then we'll do another print statement underneath. So far this is a void. This is a void function because I haven't returned anything. I'm just doing stuff. I'm just printing stuff. So die 2, okay, you rolled a. And then this one would be d2. So it's going to get, theoretically, if my program's working properly, when I call this function, okay, and I'm also going to need rolls, and I'm going to set that to 0, okay? So I need to know how many rolls it took me to get a 7. So all this program does so far is it sets some variables, some global variables at the top, and I have a function where hopefully it gets 2 random numbers between 1 and 6 and tells us what they are. So let's just do roll dice once. So I'm going to call that function. I don't need to send it anything, right? This function takes no arguments, okay? So I don't need to send it anything. If it doesn't take anything, you don't send it anything. In fact, if I try to send it something, it will break. Okay, see it broke? Okay, I'm not going to send it anything. Let's see if this works. Okay, die 1, you rolled a 2. Die 2, you rolled a 3. Excellent. So I can run that program as many times as I want. I got 6 and 1, 6 and 4. 5 and 3, great. So this program so far works perfectly. Always test it out. So what we've done is we've been able to roll the dice once, but that's not the entire program. Okay, we need to roll the dice until we get a 7. So because there's an until, we know we need an if statement, and we know we need a some looping logic, right? So we've both got to be able to keep rolling the dice. That's a loop, and we've also got to be able to test every time. and that can either be part of the loop or part of an if statement. So what we're going to do here is I'm going to roll the dice once, and then I'm going to set up a while statement. So while, while, I'll think about how I want to do this here, because I've got to put the number of rolls in here too. So I'm going to put the number of rolls as 1 to start. So the rolls is 1 to start, and it'll automatically roll because I've told it to do it once, and then I'm going to set a while with some logic. So while, while, I have to know what the sum is as well, because it's just going to print it here and I'm not sending anything. So what I need to do is, sorry, just thinking out loud here, we don't really need this, but what I do need is a sum of the dice. So I'll set the sum of the dice to 0. Okay, that should be all right. Now I am going to make this a void function. So what I'm going to do here is I'm going to send it the sum variable, okay, and I'm just going to call this dsum for dice sum. And then what I'm going to do here is I'm going to set the dsum to equal d1 plus d2. So I've done 3 things up here. I've rolled the dice once. I've rolled on different dice. I've added up what those are. Okay. I've printed off what number 1 is. I printed off what number 2 is. Okay. And now I'm going to print off the total roll is, and then I'm going to put in the dsum. And then one more thing, I am going to return dsum. All right, now that felt like a lot of stuff, so I'm going to make sure I go through it very carefully. So what I've done here is there's a function. It doesn't get run until I call it. So I call it for the first time right here. I send it sum. Currently sum is 0. So I send it sum, so currently dsum is 0. Inside this function, it rolls 1 dice, it rolls 1 die, rolls 2 die. Then it updates this, which used to be 0, it updates it to whatever the total is. It prints what die 1 was, it prints what die 2 was, it prints what the total is, and then it returns that total to here. So at this point, this number has gone up here as 0, and it comes back as something else. Okay. So we've got a rolled dice, and then it returns dsum. And I think it should update that variable, but we're just going to check this. Now let's move on to our while. So how long are we rolling? We are rolling while sum is not equal to 7. Okay? That's our logic. We keep rolling until our sum equals 7. And what do we do when we roll? We do the roll dice. Okay? Roll dice. And in the roll dice, I might have to change this a little bit, but we're just going to, we're just building it on the fly. That's what I like to do. I like to build and test and then rebuild. While sum is not 7, it's going to roll dice. When it rolls the dice, it's getting 2 dice, it's getting a sum, it's rolling it's telling you what you rolled, it's telling you what the total is, and then it's returning dice. And now I think returning the sum to this isn't going to work now that I think about it. Yeah, it's not. So this is actually going to be a void function. Okay. We'll still find out what the sum is. Okay. We'll just create a variable called dsum and we'll print it, but we're not going to send it back here. Okay. How are we going to determine? Because we don't need it down here. We've already printed it up there. We don't need it down here. What we do need to know is how many times we rolled. Okay, so every time we roll the dice, let's update rolls to add 1 to it. Okay, and then at the very end of the program, let's print it took you, and then rolls to roll a 7, or to get a 7. Okay, now let's test my logic. It very well may be a mistake in there, but I think it's okay. I set a sum, which I never use, so I might as well get rid of it. So the only variable that I have in a global sense is how many rolls. Okay, then I've got a function, but it doesn't do anything yet. Now I've got while sum is not equal to 7. I did need that sum. The only reason I need that sum, okay, is to get into this loop once. Okay? While sum does not equal 7. Roll the dice, then rolls +1, and it's going to keep doing that as long as the sum is not 7. Okay, now here's a problem. Here's a problem. Sum is never going to equal 7 because I set sum as 0, and then I never change what sum is. Never change what sum is. So at no point does sum equal 7. So this is actually just going to roll. This is an infinite loop. It's going to run forever, and it's going to break my machine. So what do I want to do? I need to change this sum in here so that it can use it here. So I think I can just call a global variable, okay, and I'll just say sum equals dsum because it's going to be the same thing, right? Dsum is here, and this is going to be sum. Now, I think that this will update this variable, but we'll find out in a second, because if my program runs endlessly, it means that there's a logic error there. All right, let's give it a shot. Okay, well, I can tell, okay, if I break this program here, I can tell there's a problem. And the reason I know there's a problem is I rolled a 7 here, and my program didn't stop. I rolled a 7 here, and my program didn't stop. So I rolled lots of 7s, and my program didn't stop. Definitely a problem. And it is indeed a logic problem based on what my sum is. I set sum as 0 here. Okay, it sets the sum down in the function, but it does not remember here. It does not remember that sum is whatever the 2 dice were. As far as it's concerned here, sum is always 0. That's why it keeps going forever and ever and ever. So there's a bunch of different ways I can fix this. Okay, a bunch of different ways I can fix this. What is the easiest way? Do I want this to return something? Yes, I absolutely do. Okay, so I'm actually going to go back to my original plan. I'm going to send it the sum, okay, and up here, we're going to set that to the dsum, okay. So I'm going to send it the sum. It's going to call that the dsum just for the function. It's going to calculate the dsum. It's going to print what the dsum is, and it's also going to return what the dsum is. So return dsum. Now, is that going to do what I want it to do? It's going to return a number for this, but returning a number for this isn't necessarily going to help me. But if I do that, it might. All right, let's give it a shot. There we go. Now it works. Okay, so there were a bunch of different ways to fix this, but I'll tell you why I fixed it the way I fixed it. And you know what? I could have edited this video and, sort of edited out all the mistakes and the logic errors and whatnot, but I want to be totally open and honest with you guys about this. This is how I program. If I had just written it out on a piece of paper with a flowchart, I probably would have taken me half the time. But I like to try things, and when I make mistakes, I like to see why they're mistakes, and I like to test my programs and step through them and figure out what's going wrong. So this is the way that I debug. If you're, let's say you've got a more organized mind than I do, you might be better off starting a flowchart or even just some rough notes on a piece of paper, solve all the logic problems on the paper, and then basically you just got to write your code out. I kind of prefer to, throw stuff against the wall and see what sticks, to use an old adage. Okay, so how did I fix this? I fixed this by changing this from a void function to a fruitful function. So instead of just sending it nothing, I sent it sum. It said originally sum was 0, so I sent it 0. It said, okay, dsum is 0. Now I get a dice roll, I get another die roll, and now I'm going to update dsum from 0 to whatever those two were. Then I'm going to print out your roll 1, your roll 2, and your total roll. And then I'm going to return that total roll down to you. So what happens here is it runs everything in here, and then it returns it. So this whole thing right here evaluates to whatever the 2 dice were together, and I set my sum to equal that. So I changed sum to equal whatever this sent me back, which was what the dice added up to. So now I have something to use for my logic up here, for my comparison. So now it adds 1 to the rolls, because I did roll, and then it tests. Did you roll a 7? If not, do it again. Did you roll a 7? If not, do it again. And it keeps doing that until you roll a 7. When you finally roll a 7, it stops doing this loop, and it goes to the very last line, which says, it took you this many rolls to get a 7. So I'm just going to test down here one more time and make sure it's working properly. I'm going to clear this out, and I'm going to run it. Okay, I rolled 1. Okay, so it says here it took me 2 rolls to get a 7, but that's not true, right? Because it took 1 roll. You know, what die 1 was 3, die 2 was 4. Together that's a 7, so I got it on my first roll. So really this should only say 1 roll. So what I do here is instead of starting at 1, I'll start at 0 because I know it's going to hit this. So that's the only change I'm going to make. All right, this time, let's see, did it work? I rolled a 4-1 for a 5, so that's once. I rolled a 5-4 for a 9, that's twice. I rolled a 3-3 for a 6, that's 3 times. I rolled a 3-4 for a 7, so it took me 4 rolls to get a 7. That checks out. I'll clear it and just test it a couple more times. Okay, I got it on my first try. It took me 1 roll. Okay, great. So everything seems to be working right. This one I rolled 1, 2, 3, 4 times, working just right. So that's an example of using pretty much everything that we need to use, with the exception of input. Okay, we used variables. Okay, we created a function, specifically remember, terminology is important, fruitful function. We can tell it's fruitful because we returned. As soon as we return something to the original call, it becomes a fruitful function. We used looping. We used logic, so that's really just an if statement in there. It's while this is true, or this is, you know, if it's not true, then we'll skip it. That's really logic. It's not a specific if statement, but it's using logic. Okay, and we used our looping, and then we gave some output at the end. So it's a good example of a quick little program. I mean, it's only 19 lines, and I've got spaces in here. But it's a good little program that includes just about everything that we need to know as the foundational building blocks of Python. So I think that gives you a pretty good run through on all of the 5 major tenets of computer science. I know the video is probably a little longer than we all wanted, but hopefully I went into enough detail to explain it, and you saw some of the mistakes I made and how I corrected them. As always, if you have problems when you're creating, when you're doing your programs, when you're doing the assignments, when you're doing the coding bad assignments, please let me know. I'm here to help you. Just send me an email.